Okay, so section 4.2, precipitation reactions. A precipitation reaction is a reaction where two soluble reactants come together to form at least one solid product. The solid is called a precipitate. Sometimes we write this as PPT. PPT for precipitate. And we predict what will precipitate using the solubility rules in this table, and you do not need to memorize these. You should be very pleased about that. You'll get to have this chart for exams. So let's just learn how to use this chart. We'll just do this with problems. So here's your facts, and now we want to find out, are the following soluble or insoluble in water, and why? So sodium chloride. Sodium, you look it up on the periodic table, it is an alkali metal. All alkali metals are soluble. So by rule 1, NaCl should be soluble. Now you'll notice rule 3 also talks about chlorides, saying that they are soluble except with these, and this is not an exception. So the rules never disagree with one another. All right, lead to carbonate. So let's see, there's nothing in here about lead or carbonate. Oh, here we go, carbonate, right there. Carbonates are insoluble except with alkali metals and ammonium, but lead is not an alkali metal. So this one would be insoluble. You try the rest on your own. I'm going to go through them, but you should pause this and try these right now. So I'm going to keep talking. You can just go right through it if you've got the right answers. Lithium carbonate. Lithium is an alkali metal. Lithium is an alkali metal. Therefore, this thing is soluble. And carbonates are insoluble except with alkali metal ions. So that also would say it was soluble. So both rules agree, and they both say that this compound is soluble. Copper to nitrate. Let's see, nitrates, always soluble. Nitrates are always soluble. Therefore, this is going to be soluble. There you go. Okay, magnesium phosphate. Look for our rules. No rules about magnesium up here, but here we go. Phosphates, look at that. Phosphates are, oh, why is that screen coming up? I'm trying to highlight insoluble. Insoluble. Phosphates are insoluble. So this stuff is going to be insoluble because this is not one of the exceptions. Magnesium is an alkali earth metal, not an alkali metal, or alkaline earth metal, not an alkali metal. Alrighty. This, just ignore for now. It's the hardest problem we're going to do today. We're going to put it all together, and I was trying to save paper, so I used that space because I need this, all of this information to go with the next page. Okay. You're going to learn how to predict the products of a precipitation reaction. So these are our steps, and I'm going to, don't worry about what the steps say. We're just going to go through examples, and we will follow the steps as we do an example. So here's a problem. You're going to determine products, you're going to balance the reaction, and you're going to identify if anything is insoluble in water. So aqueous solutions of sodium chloride and lead 2 nitrate are mixed together. We first have to identify the reactants and the charges of the ions. Sodium, you look it up on the periodic table. You should find out it's +1. Chloride is -1. Lead, they told you it's +2. Nitrate, you look up. It's -1. It's on the polyatomic ion sheet. Anything ending in 8, you look up on the polyatomic ion sheet. So now we have all of our charges of the ions. And now we need to do the second step. For the products, we're going to exchange the ions. That's what we're told. Exchange the ions. First we determine the charges of the ions in the reactants, then we exchange the ions to make the products. This is to make the products. You should add that in to your description. Okay, the positive ion from one reactant goes with a negative ion from the other, and the positive ion must go on the left side of the negative ion. So that means the positive ion from one goes with the negative ion of the other. So Na plus will go with NO3 minus, and Pb2 plus will go with Cl minus. We're just exchanging the ions. Okay, so I put the Na with the NO3, and I put the Pb with the Cl minus. These are our products. We need to balance charges to find our subscripts. That was step 3. It says balance charges to find the subscripts. So plus 1 minus 1, those are already balanced, it'll just be NaNO3. Oops, let's look at our reactants first. Again, plus 1 minus 1, just NaCl. Plus 2 minus 1, we'll need 2 of these. Here, 1 of each, and here we will need 2 Cl minuses because we have to make the total charge of a compound add to 0. So here are our reactants, here are our products. Now we balance the equation. You should be able to do that on your own, but I'm going to show you the answer. You can try it on your own if you'd like. Okay, there's our balanced reaction. And now we look at our solubility rules. We are not going to worry about the reactants for now. We're going to assume they're soluble because we were told we had solutions of these compounds. So sodium nitrate we have to check. And our rules say alkali metals, always soluble. And we had an alkali metal in there. Where did it go? It was sodium. And if you look up your rule for chlorides, it says chlorides are soluble except, oops, here's the chlorides, except with Pb2+. So when we have Pb2+ with Cl minus, that is not soluble. So this one's soluble, this one is not. Okay, we're done. Let's do the next one. So first we identify the reactants and charges of the ions in the reactants. You can do that on your own or I'll show them to you. This lithium, all alkali metals are +1. Hydroxide you had to look up on your polyatomic ion sheet. Nickel, you were given the charge by the 2 right here. Nitrate you look up. Now we exchange the ions to find out what the products are. Lithium goes with nitrate. Nickel 2 goes with hydroxide. We just switched the placement. So I just switch where the negatives are. Okay. Now these are my reactants, these are my products. I put them together and I have to balance the charges to make them add up to 0, so that's where I get my subscripts from. We've done this before when you learned how to get formulas based on the charges of the ions. So here are my reactants, I make the charges add up to 0. Here are my products, I make the charges add up to 0. Now I balance this whole reaction using coefficients. You can do that, I'm sure. Here's your answer. Check your solubility rules for lithium nitrate and nickel 2 hydroxide. Well, lithium is an alkali metal. All alkali metals are soluble, so this one is soluble. Hydroxides are insoluble. Hydroxides are insoluble. There's some exceptions, but the one we had was not an exception, so oops, here we go. The nickel 2 hydroxide is insoluble. Okay. If you want to see videos of these reactions happening, these are some videos that actually show those reactions, those precipitation reactions for each one. Okay, ionic and net ionic equations. So, an ionic equation, that's a reaction showing dissolved ionic compounds as free ions. A net ionic equation is the reaction, but we've canceled out what are called spectator ions. We'll learn about that in a moment. We cancel any ions that don't change at all in the ionic equation. Here's some rules for ionic equation, rules for net ionic equations. And we are going to go ahead and do this following the rules. So we want the net ionic equation for this reaction. We are told we split soluble ionic compounds and strong acids into ions. So you've got to check your solubility rules. You find out that the first 3 things are soluble. This one is insoluble. We already knew that because we did this problem just above. And we got to split everything into ions. So we're just recalling. You don't have to write that all down. Things that are soluble split apart. Things that are insoluble form a precipitate, stay together. This is the tricky part. So anything that was soluble splits up, and we put these little arrows saying split it up. Anything that's insoluble, say keep it together, just come straight down. And there were some rules up here. Coefficients apply to all ions in a compound, and subscripts that aren't part of polyatomic ions are multiplied by coefficients. These 2 rules are extremely important. You should highlight them, do something so that you remember this. These are the big mistakes that people make when they're doing these problems. Okay, so here's the answer. So I have 2 Na pluses and 2 Cl minuses because the coefficient applies to all of the ions. Here, notice this 2 here, I said subscripts are multiplied by coefficients. There's a subscript outside of the polyatomic ion. So 2 times 1, the coefficient was 1, so I have 2 nitrates. Here, the coefficient is part of the polyatomic ion, so I don't multiply that by the coefficient. And the lead comes straight down. I have to find my spectator ions. Who did not change? Let's see, the Na plus looks exactly the same as this one over here. So the Na plus is a spectator. And notice the nitrates on the left and the nitrates on the right look exactly the same. So those are my spectator ions. You see, and the NAs did not change. The NO3s, I have the same number of them, and they look exactly the same. So I cancel those out to get my net ionic equation. All I have left is the chloride, the lead 2, making lead 2 chloride. Now, notice this is in here, but it does not look exactly the same because here the lead is combined with something else. So I did not cancel out the leads. And the chloride is alone here and combined with something else. Okay, last one of these. We're going to find the net ionic equation again. Find out what's soluble, what's insoluble, what splits, what comes straight down. I've already done that for you. You could spend your time checking your solubility rules. So these 3 split. This one is insoluble, comes straight down. So I'll have 2 lithiums and 2 hydroxides because the coefficient applies to all ions. Now I'll have 2 nitrates here because the subscript applies to the nitrates. It's saying I have 2 nitrates. There you go. I have 2 lithiums and again 2 nitrates. This one comes straight down. So, spectators, let's see, did the lithium change? Nope, it's a spectator. Did the hydroxide change? Over here it's combined with something. It did change, it's not a spectator. The nickel changed because now over here it's with something, and the nitrate looks exactly the same. So, lithium and nitrate are our spectator ions. Net ionic equation, you just get rid of those spectator ions, and there you go, you're done. All right, that problem up here, we're going to do that one now. That was on your first page. I was trying to save paper. Okay, so first we have to identify who we even have in this reaction. We've got copper 2 chloride and sodium phosphate. So, our ions, we've got the copper 2 and the chloride. We needed our charges. Here we need our charges. And now remember we switch the negatives. So here I've got copper with the phosphate, sodium with the chloride. I just switched the places where the copper and the phosphate were. Now I have to put these together to get the formulas, make the charges all add up to 0. So this will be CuCl2, Na3PO4 to make that add to 0, Cu3PO42 to make that add up to 0, and NaCl. Okay, so there's your molecular, you need to balance it. It's balanced. Now we check the solubility rules and we find out that these 3 things split and the copper 2 phosphate stays all together. Okay, we have 3 copper 2 pluses. Now why do I have 6 chlorides? Remember those subscripts get multiplied by the coefficients for all ions unless the subscript is part of a polyatomic ion. Right here, 2 times 3, 6 sodiums. The phosphates, I don't multiply this 4 times 2. The 4 is part of the phosphate. So I only have 2 PO4 3 minuses. Over here, this came straight down, and here the coefficient applies to all the ions, so 6 Na plus 6 Cl minuses. Spectator ions, look for what didn't change at all. Cl minus and Na plus didn't change. Cancel those out to get my net ionic equation, and we are done.